Hey guys, let's look at 4.1, which is on linear functions. A lot of this is probably going to be a review for many of you, but we're going to go through it from the beginning. A linear function is a function that has the form y equals mx plus b, or if we write it in function notation, f of x equals mx plus b, where m is the slope and b is the y-intercept. Let's take a minute to talk about what those things mean. Slope just tells you how fast the line is changing. So for instance, if your line is, if it's going upward, then that's a line with positive slope. If it's going downward, that's a line with negative slope. If the line is horizontal, then the slope is 0. And if the line is vertical, then the slope is undefined. So let's do a quick calculation here. I'm going to erase this and draw in another line. Let's say we have a line like this, and it's let's say two of the points on here are, let's say that's -2, 1, and over here we have 3, 2. So the slope of this line would be, you pick one of these to make it x1, y1, and the other point to be x2, y2, and then you plug into one of these equations over here. So the top is going to be the difference in y's, so I'm going to do 2 minus 1. The bottom is going to be the difference in x's. Now you have to do this with the same order that you did before. So in this one I did this point minus this one. So I need to do the same thing for my y's. I'm sorry, for my x's. 3 minus -2. So let's see, we get 2 minus 1 is 1. And on the bottom, 3 plus 2 is 5. So the slope of this thing is 1/5. All right, the y-intercept is right here where the line crosses the y-axis. Now, when somebody says the y-intercept, they could be talking about one of two things. They could either just be talking about the y-coordinate of that point, or they might talk about the actual ordered pair for that point. So, just they're essentially the same thing. One is just considering it an ordered pair, and the other is just considering it as a number. But anyway, let's look at the equations of a line. There are two important forms of the equation of a line. There's one that everybody thinks of when you think of a line, y equals mx plus b. That's called the slope-intercept form because the slope is m and the y-intercept is b. And another one is the point-slope form. Now, point-slope form comes immediately from the definition of slope. If you have, if you take the point-slope form and you divide both sides by x minus x1, you get m is y minus y1 over x minus x1. And that's useful for writing the equation of a line if you're given a slope and a point. That's why it's called the point-slope form. Another one that it's not really going to come up much in this class, but the general form is this, where you've got ax plus by equals c. The b here is not the same as the b up in the other problem. General form is nice because you can represent vertical lines with this form as well. And if you take linear algebra, you'll see this is the way that linear equations are written a lot of the time when you're considering linear equations in several variables. But in this case, it's just two variables, and the ones that we're really going to use are going to be these two up here, the slope-intercept and the point-slope. So let's do some examples. Find the equation of the line through these 2 points using the point-slope form. All right, pretty much any problem like this, first thing to do is find the slope. Let's call this point here x1, y1. This one x2, y2. So it's the change in y. So I'm going to do 11 minus 3 over the change in x. 6 minus -4. So let's see, 11 minus 3 is 8. 6 plus 4 is 10. So that's going to be 4 over 5. So that's my slope. And now I can pick either one of these points. I'm going to pick this one. And I'm going to plug into the point slope form. So I've got my m, and I've got my point. So I'm going to do y minus y1 equals m times x minus x1. Let's see, x1 was 6. So we get 4/5 x minus 6 times 4 is 24 over 5. And let's see, if I add 11 onto both sides, let's see, 11 is 55 over 5. So 55 minus 24, I believe, is 31 over 5. Yeah, that should be it. Okay. Now the second part says do it using only slope-intercept form. To me, and it's probably just because I learned to do it this way, this method up here that we already used seems like the more natural way to do it. But you can do this by just using the slope-intercept form. What you've got here is y equals mx plus b. We just found out that m is 4/5. And we can pick either one of our points to plug in for x and y. So m is 4/5. And let's use x is -4 and y is 3. I'm just picking the second point. First point would also work just fine. So plugging those into here gives me 3 equals 4/5 x, or well, x is -4, plus b. So 3 equals minus 16 over 5 plus b. So b is 3 plus 16 over 5. Well, let's see, 3 is 15 over 5. So I've got my b, I've got my m. So y equals mx plus b. So you can do it this way or the other way and you get the same answer. I don't care which way you do it. To me, this up here is the more natural seeming way to do it, but they're both perfectly fine. Let's do a few more examples. Find the equation of the line that goes through these 2 points. All right, my slope is going to be, let's see, we'll do 9 minus 3 over 5 minus 2. So that's going to be 6 over 3, which is 2. And I can pick either point. I'll pick this one. Y minus 3 equals 2 times x minus 2. So I get y minus 3 is 2x minus 4, or y is 2x, let's see, minus 1. Right. We've got a handful of other examples that I want to look at here. Find the slope in the equation of the line that has x-intercept 4 and y-intercept -9. All right, I'm going to graph this. Let's see, y-intercept is -9, so I need a lot of space under the axis. And x-intercept is 4. So that means this line looks like this. Down here, this is -9, or I'm going to write it as 0, -9. And then x-intercept 4, that tells me that this point has x-coordinate 4 and y-coordinate 0. So my slope is going to be, let's see, 0 minus -9, change in y, over 4 minus 0, the change in x. So that's 9/4. And I could go through with plugging into the point slope form or whatever, but they've already given us b. The y-intercept is -9, so this is equal to b. So my answer is 9/4 x minus 9. All right. Find the equation of the line that goes through these 2 points. All right, so we'll get the slope. Let's see, for my slope, I'll do, just to be different, I'm going to do the first one minus the second one this time. 7 minus -1, and then over 4 minus 4. We wind up with 8 over 0. That's undefined. So what that tells us is it's a vertical line. We can still write the equation of it though. Notice both of these points have an x-coordinate of 4. So if I were to plot both of them, we'd have 4, 7 up here, and then 4, -1 here. So what we'd have is this vertical line here. That's the vertical line, x equals 4. All right, one more example. This last example says a line passes through these 2 points. Find its equation and its x-intercept. All right, so let's see. The slope is going to be 9 minus -3. Oh wait, I need to be careful. It's going to be 9 minus 4, change in y, over -7 minus -3. 9 minus 4 is 5. -7 plus 3 is -4. So my slope is -5/4. So find the y-intercept. We can use either point. I'm going to use this one. Y minus 4 equals -5/4 x minus -3. Let's see, 3 times 5 is 15. 4 is 5 over 4. No, 4 is 16 over 4. So get -5/4 x plus 1/4. By adding that 4 onto both sides. So that's the first part of the question. But it also says, what's its x-intercept? So, we've got this line. It's got a y-intercept of 1/4, and its slope is -5/4. So it's going to be going downhill. The x-intercept is going to be whatever this point is over here where it touches the axis. So the way you solve for this is, at this point we know the y-coordinate is 0, but we've got to figure out what that x-coordinate is. So what we do is we just plug in 0 for y. So I get 0 equals -5/4 x plus 1/4. I'm going to move the 5/4 x over, so I get 5/4 x equals 1/4. And I'm going to multiply both sides by 4. 5x equals 1. So that gives me x is 1/5. So my x-intercept, I could either write it as 1/5 or we could write it as the point up here, 1/5, 0. All right, that'll do it for this video.